What is up, nerd friends? Welcome back to the Nerd Bench. We're going to take a look at the XR10 Pro G2S and some of the things that you should know when you open this up to get it installed. First and foremost, the big thing that gets overlooked is calibration. Folks put a new speed control in and they overlook the calibration, so we're going to try to look at that first and foremost. All right, so up first is going to be calibration. The first thing you should do before you worry about tuning or driving your vehicle. You do the install and then you want to do basic calibration so the speed control can learn the neutral, the throttle, and the full reverse or brake output of your radio system. Radio is turned on. I have it plugged into the throttle channel of my receiver correctly. If you need to figure out the orientation because all the wires are black and these will fit both directions, there is lettering etched onto the very edge of the plastic of your speed control wire so you can tell which direction it goes. Make sure that it matches your receiver so that works correctly. To start the calibration process, it's a long press and hold of the power button and it'll start to blink and then you'll let go and go through the process. Or long press and hold, light comes on, it'll start to blink, we let go, we tap to set neutral, hold it full throttle, tap again, hold it full reverse, tap again. And that is basic calibration. Once it gets done, it'll blink at you like this because the speed control is in zero timing mode. That is the blinky mode for non-timing racing, but everything here is working. The speed control defaults with the reverse turned off, so you won't have any reverse, you'll just have brakes. But you get a blinking light at neutral for blinky tech, and then as you give it throttle, it flashes green, and as you get to full throttle, you get a solid green light. Never free rev your stuff in the bench. This is a 17.5. So up next is going to be tuning of your XR10 Pro G2S. It can be done two ways, with the OTA module sold separately or with the LCD program box also sold separately. Either of these devices can change the settings that are inside the speed control, no problem. The OTA can also be used to do firmware updates to the speed control. The LCD box can as well. You just require a Windows PC, and it has to be a genuine Windows PC. You can't run like an emulator and run Windows or whatever. It has to be like an actual Windows PC. So that can be tricky. So if that's an issue, OTA may be a little bit easier. In addition to that, the speed control has built-in data logging. It'll give you some very basic minimum voltage, maximum temperature, maximum RPM. And with the OTA installed in your vehicle, when you drive around with this installed, this acts as an additional data recorder, and we'll show you some of that stuff here in just a second. So up first, tuning. If you use the LCD box, it has this double-ended harness. This guy plugs into the programming port on the speed control. If you're using an OTA, same thing. It is marked for orientation. Make sure that you get that correct. This guy plugged in there. Still have the receiver hooked up. If you have any problems with this process, your receiver may have a failsafe or maybe you didn't calibrate it yet, you just unplug the speed control from the receiver and that usually makes all the tuner stuff work fine. So we turn on the speed control, my OTA comes on, I open up my HWLink V2 and I tap this little icon in the corner. I can see there I've renamed mine Charlie OTA. Default passwords are all the same, all 8s. It even says it up there for you in case you didn't know. Hit that save it. Hit confirm, and it brings us into the speed control. So to get into the speed control settings, you don't go to settings. That's the settings of the app. You're going to go to parameters. That'll let you see the speed control, and you can do firmware updates in here. For the sake of covering all the basics, we'll go in and do a firmware update real quick. This is already updated, but it'll do it anyway. But you'll see your speed control information up here, the current firmware that it's on, and any that it has available for updates. Since this is already updated, we're good to go. I'm going to hit the button so you can see what goes on here. Very important that if it comes disconnected during the update, you can break the speed control. And in those situations, sometimes the LCD box is the only way to bring them back, sometimes not. But make sure that your phone is in whatever airplane mode. You're not going to take a call in the middle of this process. You're not trying to pair speakers or do anything goofy like that because it can interrupt the process. Hit OK, and then it goes through the process. And it does take a little bit of time. We'll leave that playing. Update completed. So typically after you do a firmware update, it's kind of like a factory reset on the speed control. It'll undo any setting changes you have. So make sure that if you're going to do a firmware update, you double check all your settings and make sure that's good to go. So we have to relink to the speed control. Click on that. We already saved the password, so we're going to get right back in. And we'll take a look at the speed control parameters. We get asked all the time what all the settings mean. The instruction manual has this explanation, but sometimes it's a little easier just to run through them here. So up on the top here, you have your reset, your import, your export, save, and rename. Rename is where you can change the name of your profiles, or you can select from the different profiles that the speed control has available. So if you go from one track to the next, and you don't want to change your settings every time, or maybe you run a different motor at different tracks, you can do your preset profiles in here and name them all accordingly. Reset will reset the profile to the factory default. If you do run into any issues, if you're doing an old firmware update to a new firmware update, going in and resetting your profile is not a bad idea to avoid any problems or any mismatching. Or if you do have any operational problems after a firmware update, do the profile reset. That'll usually take care of it. You can export and import profiles, actually. So if you get a profile in your phone that you're going to want to put into another speed control that's the same exact model, you can export it to the phone and then import it back to the speed control. And then any settings that you make on the speed control, in order to save them, you can't just change them. You have to actually hit the save button that's up at the top. So don't forget that. So folks, if I made all these setting changes and nothing kind of sticks, it's because you forget to hit save. So now we're going to get into the settings. First up is our general settings. The running mode is, you can turn the reverse on here, and I most often want to have reverse. So you can do forward with brake, forward reverse with brake, or forward and reverse. That's the rock crawl style of throttle operation, where you have the instant reverse and no push brake. Max reverse force is how strong your reverse is. Some of us aren't very good at using reverse, so you can turn the reverse overall power down. You can set the cutoff voltage to a specific voltage that you're looking for with these guys. Now, you may set it to, let's say, 6 volts, and you bring your battery in, it's going to be a little bit above that, or you may set it to, 6.6, and you're going to be a little bit above 3.3 per cell, or a little bit below that. The voltage cutoff isn't always going to match this number exactly because of the conditions that the battery's under during the discharge, how healthy it is, connection quality, all that fun stuff. ESC thermal protection and motor thermal protection. On a HOBBYWING motor, there are temperature sensors inside that can help save your motor from overheating. Same on the speed controls, there's a temperature sensor inside that is adjustable in a low and a high, or you can disable it as well. BEC voltage, you can change that in one step, or 1 point. You can change that in 0.1 increments all the way up to 7.4 volts. People often ask, why doesn't it go to 8.4? Because it's an 8.4 battery. So as soon as it discharged a little bit, you'd be losing steering power consistency. So it's better to have it closer to the cutoff voltage of the battery for consistency. The remote off, the speed control has the ability to, when you sit in the pits, you can hold the brake to turn the speed control off. So if reverse is turned off, that's very handy for being able to turn it off from the driver's stand. And then in sensor mode is going to be the ability to work with dirty sensors. If you run a HOBBYWING motor, leave it full censored. If you're running anything other than that, you can run it in the hybrid mode, and it allows it to deal with less than clean sensor information from the motor and still operate correctly. Moving through our general settings, we get to motor rotation. If you have a backwards transmission vehicle and you give it throttle, the tires spin backwards. This is all after calibration, of course. Motor rotation is the way to fix that. In sensorless, this is not a sensorless system. It'll run sensorless, but we have them typically set up censored. You can't just switch the motor wires to get the direction correct. That's a very dangerous and bad thing. Speed control can kind of blow up. So this allows you to change the forward rotation of the motor. Normally it's counterclockwise for typical vehicles, and some of them require a backwards motor, and that's what the clockwise mode is for. Phase AC swap is for like the super clean installs. If you don't like the order that the motor wires are going to the motor and you want to swap those two outside wires and still have the direction and still have censored motor operation, phase AC swap allows you to do that. It makes the A terminal on the speed control the C terminal on the motor. Only do that if you're doing super clean installs and you totally understand what I said already, because if you don't, it's not for you. We move up here now to our next one, throttle control. Throttle rate control is how linear the throttle is. For most applications, you're going to leave this at 30. It's going to affect the relationship of how quickly you move the trigger to how quickly the motor responds. 30 is linear, so whatever you do with your trigger, the speed control is going to do that. And any lower you go, the slower the speed control is going to react to your throttle inputs. It helps a lot with slick track conditions more than anything else. If you're having a real hard time getting on power, that can help kind of tame that down a little bit. For some guys, they run as low as like 10 or 15. Some of them stay up in the 20s. It's kind of a personal preference and what you're used to. Everybody's kind of twitchy throttle fingers a little bit different. Throttle curve, this allows you to set a customized throttle curve, just like you would in your radio with multiple pull points. You can set this however you need. I typically run it linear because that's just me. Some people do mess with that a little bit. Neutral range is the deadband between, let's say this is your brake pulse, this is your throttle pulse. You can make that wider or narrower depending on what you need for input. If you're real twitchy at neutral, increasing the neutral range can help get that out. If you still notice that your drag brakes are kind of inconsistent, increasing the neutral range can help that as well. And it stems from the radios have a mechanical throttle pot, and those can kind of wear over time. So even though you're not changing the neutral, it does shift the output a bit, and this can help deal with that. Initial throttle force is the startup of the motor, and it helps a lot if you don't like that kind of dead spot that happens with some throttle inputs. If you want the motor to move as soon as you touch the trigger, initial throttle force can help with that. It's kind of like a punch setting a little bit. Coast is like a run-on. If you get into a situation where even with the drag brake turned off, the natural deceleration of the motor is too much, it upsets the car, makes it want to spin out. Coast allows you to put a little run-on in. So you can use that to help with very, very loose conditions when you get off throttle to make it coast or not decel when you let off the throttle. PWM drive frequency is the duty cycle that the speed control operates the motor at. It changes the feel very directly. Lower frequencies are going to feel more aggressive. Higher frequencies are going to feel a lot smoother. Softening value and softening range are used to basically take away power. For some racing conditions, there's got too much power, and this helps with that traction. It's kind of like a reverse timing or a current limiter situation, that the value is how much limiting you give it, and the range is what part of the trigger it applies it to. So you can have it at a very, just the initial part, it'll make it real soft, or you can have it like all the way up to like 50, I want to say it's like 50%. Oh, 75% for the softening. And then once you get through that percentage, the softening turns off. So the motor's kind of up to speed and everything is back to normal. Oh, and another thing is in blinky mode racing, softening is not legal. So if you use softening, blinky won't work. So that has to be set to 0 for blinky, in case you didn't know. Brake control. This is where you fine tune your brakes, obviously. Drag brake force is the strength of the brakes at neutral. It's not drag racing brakes. And you definitely don't want to use drag brakes if you're doing drag racing. Another pro tip. It applies the brakes as soon as your throttle gets to neutral. For track applications, a lot of touring cars run drag brakes. Some of the off-road guys run drag brake. Spec guys, maybe not so much. Most folks run with little to no drag brake at all in spec racing, just to help with temperatures and stuff like that. Because it is applying brake whenever you're coasting the car. Your drag brake rate is how quickly it applies the drag brake. So normally you'd let off and you'd be at neutral, you get all that drag brake right away. This allows you to fine tune how fast it pushes on the brake pedal, if you will. Max brake force is a lot like the reverse force. It's how strong the push brake is. For some motors, they got way too much push brake, so this allows you to fine tune that in the speed control, and then use your radio as a secondary area to kind of fine tune that on the drive for your brake endpoint. Brake rate control is going to be just like the throttle rate control and how linear it is. It slows down the reaction of the brake inputs from the speed control to your finger inputs. So if you find that your finger's like too jumpy on the brakes, you can turn that down to help with that. Brake frequency, again, like the drive frequency, kind of works similar. The lower the frequency is, the more aggressive, or I guess bitey you'd say the brakes are. The higher the frequency, the smoother they're going to feel. And brake control, again, you can do a custom curve in there as well. Now we get down to the fun stuff, the timing. This is where open class racing started to, I guess, why Blinky came around is because these things started to exist. A lot of speed controls, HOBBYWING included, have two types of electronic timing advance. And what electronic timing advance is the speed control overfiring the motor for the way that it's supposed to be running, so to speak. And why wouldn't you do that all the time? Well, it creates temperature problems, and you're going to have too much, and it does current drains that are crazy. So it allows it to be very, very tunable with two types. Boost timing applies the electronic timing between the RPM that you set it to. So you can have it to start at 1 RPM and finish applying by another RPM. Turbo timing only applies the timing after you get to full throttle. And then all of the timings add together. So your boost and your turbo add up, and they also add on top of whatever end bell timing you have. So if motors can have way too much timing and kind of be very inefficient and have some heating issues and not gain any performance. And that's why this stuff is so dangerous. And we say use it very, very carefully and wisely. Always start it with very low amounts of timing, work your way up. Start out with wide boost RPM ranges. Start it with slow turbo delays and increase rates and stuff like that until you get a feel for what you're dealing with here. At a glance, this stuff all looks very confusing, and that's because it is. So you get boost timing as your first one. That's how many degrees of boost it's going to apply, and you can have it activate two different ways. Automatically, the speed control looks at the ramp curve of how quickly the motor is accelerating, figures out when it wants to dump that in, or what you have control of over the RPM. So you can set your start RPM as, I went all the way up, as low as 500 RPM, so it starts just to kick that, or what does that say? Oh, yeah. As low as 500 RPM, so it kicks that in right away, and as high as, you see it goes way way up there to 60,000 RPM. So that would be the widest range that you could have. I wouldn't try to use that low of RPM. You want the motor up to speed before you start kicking any boost and use it. But those are just examples of what's going on here. So that's going to apply as you work the motor through that RPM range, or kind of through your trigger position, depending on how the motor is responding, all that, obviously. Turbo timing, similar. You have your amount of turbo in degrees, and then you have a delay. So that's how long after you get to full throttle before the speed control starts to apply that timing. Your turbo increase rate is how quickly it dumps that timing on in degrees per tenths of second. You can change that to up to instant, so it comes on right away, or 30 degrees every tenth of a second, as low as 1 degree every tenth of a second. So you can have the turbo feed in very slowly to build the RPM. And the decrease rate is kind of the same thing, but when you let off the throttle, how quickly it takes the timing away. And this is to help you deal with decel, because as the motor has all that timing in it, if you take it away too fast, it'll feel like it has very high speed drag brakes. This allows you to fine tune that stuff. And then we get down to the bottom here, the data record. The speed control has built-in data recording. It does max temperature of the speed control, max temperature of the motor, if you have a HOBBYWING motor, minimum battery voltage, and the RPM that the speed control saw. So if you hold the car up in the air and rev it up, it'll tell you a basic max RPM. If you don't do that, it'll tell you the highest RPM you got, like on the straightaway on the track. If you're doing speed runs, that sort of thing as well. So that's a real quick at a glance for the data logging that the speed control itself has built inside of it, and you can just jump into parameters and view that right here. There is a very advanced feature that I want to spend a little bit of time on, and that is in the drive frequency area, or the brake frequency for that matter. They both have this feature. You can do customized throttle curves for the frequency itself. So you can change where in the throttle the drive frequencies change on the speed control, and you can get very customized feels for initial throttle, late throttle, and things like that. It's used a little bit in spec racing to help with that punch versus smoothness on the top end, to help with dealing with track conditions changing and things like that. So once you get the hang, and then you can make this thing go sideways so you can get your chart a little bit better. And I will say, like, using these guys, it's a little wonky, but once you get in here and play with this a bit, like, it starts to really get used to your finger, and you can make it all happen. But you can set, like, for example, this one would be a lot of rip up front, and as we get up to speed, it's going to smooth out the feel of the motor. So just a quick look at one of the cool features. It kind of gets overlooked because it's a little scary to use, but if you like to play with throttle feel and you're not happy with the way the power delivers across the trigger pull, if you will, PWM drive frequency and the customized guy will help you get down on that. We're going to take a look at some of the more advanced features that the data log has to offer, including the OTA's data logging features. We're already connected to the speed control. We go into data log, and you can look at the data records that the speed control has saved in it. So since I've only used the speed control once or twice, there's 2 of them here, and you can see, like, if you want to go back and look at your whole day worth of runs, it'll keep all that stuff in the speed control for you. Pretty cool feature in case you forget to check that stuff. But what we're here to see is the real-time data, because that shows us a couple different things. On this screen, you see the live output from the speed control itself. The throttle position, if I give it throttle, that changes. The RPM of the motor, the speed control's battery voltage, and the temperature of the motor and the speed control as well. Some of the speed controls have a current sensor. You'll see that here. This speed control does not have a current sensor. But with this kind of cool interface as a benchtop tuner, you could use this kind of as a benchtop dyno, if you will. You set a car up under some load, and you can run it a bit and see kind of what kind of voltage drop you're getting, temperature increases, what RPMs, get an idea. So it's a pretty cool feature. Now, this is not made to drive around the track and review this on your phone while you drive. Bluetooth only has like a 30-foot range, give or take, and unless your track's 20 feet long, that's not really going to work great for you. I suppose if you wanted to, you'd have someone stand in the middle of the track and try to keep tabs on it. But overall, the real-time data is to show benchtop stuff, so you can get an idea what the speed control is dealing with. In the real-time data screen, there's history. You go in there and you can view the history from the OTA, and that'll show you the files that the OTA has saved into itself. I think this one is the last one. You can click the file, you view it, it loads it up, and then you get this very cool graph setup that you can zoom in and pick different parts of your run, scroll through. You can turn the different features on or off, and it records your whole run for the most part. It's several minutes that these guys do, more like 10 minutes or something like that, I forget. But each run you can go in and view this stuff. We're working on making this exportable so you can view it on your computer, but if you wanted to go and look at speed runs, or in a situation where you're running laps, you can actually do a pretty good job of picking up the full throttle points that are the straightaway, so you can pick apart laps pretty easily and see, scroll through and watch lap by lap. So kind of an overlooked feature that we have. But we back out of there, and we get back to the front. And then once you're all done with all that fun stuff, you disconnect. But to get that extra data logging, you do need to have the OTA installed on the speed control itself. So this is all stuff for the XR10 Pro G2S. Similar features are available on most of the G2 or G3 versions of any of the speed controls that we have in the lineup. You just need to check the instruction manual to see if it has the real-time data and the enhanced data logging feature listed. Don't forget, we have a podcast. It's called RC Stuff, powered by HOBBYWING. We give away a free HOBBYWING system each and every episode. All you have to do to find out how to enter to win is listen to an episode. Just look up RC Stuff on your favorite podcast service. If you do have any questions, comments, or concerns, you can reach out to us directly. Just send us an email, northamerica@hobbywing.com. If you want to talk to me, just say, hey, send this to Charlie. They send it right to me. If you want to talk to the office manager, say, hey, this one's for the office manager. Everything gets filtered through northamerica@hobbywing.com. And as always, folks, thanks for watching another episode of The Charlie Show right here on the HOBBYWING official YouTube channel. We will see you all next time.